Hey viewers, welcome back. Let's complete the model where we left. So till now we have created the model. Now we are going to create the compilation. Just read this out. Now model dot compile, give out the optimizer. I'll be giving the default optimizer Adam and give a loss function out there. As loss function, I'll be giving tf.keras out there, losses dot sparse categorical. So this should be the loss function, since we are going to classify for more than 2, that is around 10 categories of labels out there, and which are not hot encoded. So we have 0, 1, 2, 3, 4, 5, 6. The labels are like this. If we have a hot encoded, one hot encoded labels, then we can use categorical cross entropy. So for now, let's just use sparse categorical cross entropy. Then write out their matrix. So matrix is accuracy. So I want to track accuracy. So now model dot feed, I want to feed the model with X train out there and Y train, and give epochs out there. So firstly try with lesser epochs, and after that you will give larger epochs and write out their epochs. Okay, validation data, give a validation data out there, give out their x trace, yeah, and y test. Okay, that's it. Now model, okay, assign this, write out there as history. So write out their history. Now I want to have a plot out there, so plot dot give a write a figure name out there, figure 1 now equal to fig 2. Okay, give out that fig and give a fig size out there. Okay, I'll be just plotting my, give out there, so fig dot plot. So I'll be plotting my history dot history. So I'll be plotting history of accuracy. So accuracy versus epochs. So you can give epochs out there or just left it out. I am leaving it out, and give a labels out there. So label equal to accuracy. Okay, now fig dot show, plot dot show. Okay, I will be showing this later. Now I am plotting the accuracy. Now I want to predict the model. So model dot predict. So give out the X train. So give out the X test and have this in prediction array. So I'll be having a prediction array. Okay, now I want to evaluate the accuracy. So loss accuracy equal to model dot evaluate. So I'll be evaluating, give out their X test and give out their Y test. Okay, so just print the accuracy, print accuracy. Now I want to, okay, so let's check the model for now. Yeah, hopefully everything is fine. Okay, run the code and wait for a while for the compilation. Okay, I have matrix, so this is an error out there, matrix equal to, okay, there is an error, received unwanted. Okay, I have to give out there from logits equal to, so I'll be using logarithmic logic. Okay, now everything should be fine. Okay, it has started its compilation, you can see. So after a while you can, so you can see accuracy is increasing. I'll be pausing here for a while. Okay, I have error out there, figure 2, and I didn't show the plot, so plot.show. So I have to run the code again. So run the code. Wait for a while. I will be pausing for some time. Again error. Right on the plot. Hopefully everything should be fine now again. So here it is. It is the plot of my accuracy versus epoch. For only 3 epochs I am having this validation accuracy of 60%. Not bad. If I go for further epochs, let's make these epochs of 15. Okay, and try run again, run the code again. Not bad. Okay, so run the code again. Let's check. So it will take a time. So just I'm pausing from here. So here it is, and you can see for 15 epochs my accuracy, this is the graph of accuracy, and after 15 epochs it is flattening. Okay, so accuracy will not increase, and you can see out there for my data or trained data, it has an accuracy of 80%. Okay, and for my trained data, test data, I have an accuracy of 65%. So it is lower than the train set. Okay, and I have overfitted, and if you try with 10 epochs, you can see you will have a generalized accuracy of 70%. That is better than this one. So in the next tutorial I will show you how to plot graphs of the predictions. So this is all for this tutorial. Thanks for watching.